Welcome to my channel again. This is King's Bread TV. In this episode, we'll be taking an example under collision. And the example is right here before us. It's a very simple question. Like, this makes physics very interesting. You're gonna like this. It says a ball of mass 0.05 kg moving at 10 meters per second collides with another ball of an equal mass or at rest. If the two balls move off together after the impact, calculate their common velocity. Now you need to pay attention, and this is how I teach my students even in class. I let them to know that before solving any problem, understand the question, identify your parameters. The moment you do that, you'll be able to solve the problem without any headache. All right, now so let's go ahead again with the question. A ball of mass 0.5 kg. Now we have a ball, so let's draw a ball. Follow this carefully. Of 0.5 kg, so we can put 0.5 kg right in the circle. All right, collides with another ball of equal mass. What does that mean? It means that there's another ball somewhere here of 0.5. now this time around, the ball in question is at rest, while this one moves at, that is the initial velocity of that is 10 meters per second. 10 meters per second, right? Now, so what that means is that this particular one is at rest, so it's not moving, so we are not going to put this arrow. So it's at rest, 0.5 kg, and this one is moving with 10 meters per second. So we can say this one is M1 and this is M2, and so we say this is before collision. All right? Now, so let's now look during a collision, because the question said collides with the ball at rest. So let's look at the impact. I'm going to draw this, then make a line straight. Don't mind my structure. Now then they move off with V. Now so we still have their 0.5 kg both, and then they are both mass M2 and M1, so 0.5, 0.5. Now very quick one. This is after collision, like I explained to you in the former video, right? This is after collision. Now what we are looking for is V. So we are going to apply the principle of conservation of linear momentum, right? Which is, let's just go ahead. We are going to state it first, given that mass M1 equals to 0.5 kg, then mass M2 equals to 0.5 kg likewise. Now, why we have initial velocity to be 10 meters per second, and then we have final velocity to be unknown, which is the common velocity, right? So we'll be applying the principle. Now, which principle are we applying? Very simple principle. We just say M1U equals to M1 plus M2 all in bracket V. Are you there? So how do we go now? Now we are going to pick M1 because it's mass 1 with its initial velocity. So we say M1, which is 0.5. What is our U? Our U is 10. If you look at it, 10. So we introduce 10 equals to open bracket. M1 is 0.5 plus 0.5 again. Close the bracket. V. All right, so our next step we say 0.5 times 10. Are you with me? The next thing we put there is 0.5 times 10. And if you get 0.5 times 10, all right, that will be, let me punch my calculator from here. 0.5 times 10 should be 1. All right. Sorry, that's 5 rather. 5. So we have 5 here equals to 0.5 plus 0.5, that is 1. So we can just say 1V. That means we're having V in that case. So if you write it, therefore V equals to 5 meters per second, and that is the answer. This is very simple. You're gonna enjoy this, and if you enjoy this video, kindly subscribe to this channel and share this video to your friends who will want to know more about physics. I am King's Bread. Have a nice day.